yet another example. So in this example, we asked to find the resultant of this whole system, right? Find the resultant of these forces represented here. Now, first things first, observe that they've already labeled F1, F2, F3, and F4 for you already. Alright, they've done that for you already. So you don't have to stress with that. All you have to focus on now is getting the angle. Alright, focus on getting the angle. Let's start with F1. So F1, we said is 150. Let's get theta 1. Theta 1 is equal to 30 degrees. So F1 is inclined at 30 degrees to the horizontal. So F theta 1 becomes 30 degrees. F2, as you can see here, is 80 Newton. The angle theta 2 is equal to 20 degrees. But observe, this 20 degrees is the angle of inclination of F2 to the vertical. Observe, is to the vertical, not the horizontal. So let's say this is equal to 20 degrees. Just to remind me that this one is to the vertical, perhaps I will just aesthetics it a bit. So please note that is to the vertical, not horizontal, please. Alright, F3 is equal to, it's here. Okay, question, what's the angle of inclination? Observe that F3 is inclined at what angle to the horizontal? This is my horizontal, positive x. So question, what's the angle between F3 and x? If I look at this diagram correctly, I can see this. That's this. 90 degrees. Right. So F3 is equal to, theta 3 is equal to 90 degrees. And then theta 4 is equal to what there? 15 degrees. Observe that theta 4 or F4 is inclined at 15 degrees to the horizontal. So my horizontal as reference, this F3 to horizontal is 90, F1 to horizontal like this is 30, F4 this to horizontal like this is 15, F2 it is not inclined to the horizontal, that's this, is inclined to the vertical instead, that's this one instead, that's 50 degrees. Alternatively, if to make it easier for you, you can choose to find, so the question is this, if F2 is inclined at 20 degrees to the vertical, what will be the angle of inclination to the horizontal? What will be this other angle here? Of course, this angle here is 90 degrees, right angle. So if this is 20, here has to be what? 70. So you can come and put your angle here, you can come and do this like this, and call this 70, and just use 70 and so. But it will still give the same answer though. But for now, I choose to work with the angle, so I'm using 20. But don't forget, it's to the vertical. Alright, let's get summation of forces. So summation of horizontal forces. Sigma Fx is equal to, start with F1, of course, to the horizontal, that becomes F1 cos theta 1. Next up, F2. Bringing back my quadrant idea, bringing back my quadrant, positive x, positive y, negative x, negative y. So say here, quadrant 1, positive x, positive y, quadrant 2, negative x, positive y, quadrant 3, negative x, negative y, quadrant 4, positive x, negative y. This one here is now in quadrant 2, this way. That becomes negative if I'm resolving to the x. So it becomes minus F2 minus F2. Now usually, resolving to the horizontal is supposed to be cos. But don't forget, the angle of inclination here is to the vertical. And in our previous discussion, we said when you have the angle of inclination as being to the vertical, then the horizontal component F is equal to what there? F2 sine. Please, it's now sine, no longer cos. Why? angle of inclination is to what there? The vertical, not horizontal. Alright, so cos sine theta 2. I have this. Next up, let's look at F3. F3 is this way here. So F3 should be positive or negative. Alright, so we said here is positive x, here is negative x, but F3 is lying straight down like this. So at this point here, is it positive of x or negative of x? The answer is that you use it as what there? Positive, please, not negative. Alright? This one here is at the very center of positive of x and negative of x. Please, we use it as what? Positive, not negative. Alright, so it becomes plus F3. It is inclined at 90 degrees to the horizontal. Please observe. Between this and the horizontal is 90 degrees. So it becomes what there? Cos. So I'm having cos 90. Then finally, this one here, F4 is in quadrant 4. That's this way, quadrant 4. If I resolve this one horizontally, it gives you positive of x. It becomes positive of F4, then theta 4, or cos theta 4. Cos theta 4. Please, this is cos because angle of inclination towards the horizontal. Alright, let's impute values. This is equal to F1, 150. F1 is 150 cos theta 1, 30 minus F2, 80 sine theta 2, that's 20. Let me stress this one again, please. I said this is sine because the angle of inclination is to the vertical. I also said if you want to, you can choose to use the angle of, use this idea that here is 90, if this is 20, here will be 70. That means 80 is inclined at 70 degrees towards the horizontal. That means I can still come and use F2 cos 80. I'll have exactly the same answer. So instead of using sine theta 2, I can still use cos theta 2. But theta 2 in this case becomes what there? 70 instead, please. So this would now be minus 80 cos 70. I will still have exactly the same answer. So when we are done, you can choose to use that value, and you see that we'll have the same value, the same answer. Alright, so plus F3. F3 is this 110. We said to the horizontal, as you can see this, to the horizontal is 90, so it becomes cos 90 and then plus F4 100 cos theta 4, that's cos 15. Alright, so this is equal to, I'll get the calculator and punch these values. So I'm having 150 cos 30, that's 129.9038 plus, okay, minus, so minus 80 sine 20, 8 sine 20 is 37.3616 approximately, plus 110 cos 90. 110 cos 90 gives 0 plus 110 or 100 cos 15. This gives me 96.5926 approximately. So therefore, sigma fx is equal to, let's say it's 129.9038 minus 27.3616 plus, of course, plus 0, doesn't matter, plus 96.5926 129.5926. Alright, just confirm this. 129.9038 minus 27.3616 plus 0 plus 96.5926. So this will now give me 199.1348 Newton hour. Alright, so this is the summation of horizontal forces. Let's now get summation of vertical forces. Okay, so let's look at the summation of vertical forces. That's sigma Fy. First, let's get the equation. So for the equation, F1 going this way would be F1 sine theta 1, of course, because the angle of inclination is to the horizontal, so that's it. For this one here, since the angle of inclination, okay, but before then, resolve this to the vertical, that's this one here, to y. We said at this quadrant, y is positive, so it becomes plus F2, since the angle considered is inclined, or since the force is inclined to the vertical, it becomes what there? A cos instead. So cos theta 2. Alright. F3 is F3, now look at this. F3 is pointing this way here. If I compare this with my Cartesian coordinates, F3 will be lying perfectly here. F3, that's perfectly downward like this, which is negative of y. So it becomes negative. So minus F3, of course. The angle of inclination is to the horizontal, that's 90 degrees. That's sine 90, okay, sine theta 3. Excuse me, sine theta 3. So you know why it's negative, right? Because it's lying downwards, negative of y. Finally, F4 this way. So for this quadrant 4 this way there, we said if you resolve this to the vertical, that will be this way, so this way, which is negative of y. So we said negative of y becomes minus F4 sine theta 4. Sine theta 4, because the angle of inclination is what? To the horizontal. So we have this. Alright, input values is equal to F1, that's 150 sine theta 1. Theta 1 is 30 plus F2. F2 is 80 cos theta 2. Theta 2 is 20 minus F3. F3 is 110 sine theta 3. Theta 3 is 90 minus F4. F4 is 100 sine theta 4. Theta 4 is 15 degrees. Alright. So I'll get a calculator and punch these values. So I'm having 150 sine 30, that's 75, plus 80 cos 20, that's plus 75.1754 minus 110 sine 90, that should give 110 minus 110, then minus 100 sine 15, that's about 25.8819. Alright, so therefore the sum of all vertical forces is equal to 75 plus 75.1754 minus 110 minus 25.8819. That's about 14.2935 Newton J. So I have this. This becomes the sum of all vertical forces. Alright, so finally let's now get the resultant in vector form and also its magnitude and perhaps also its direction. Alright, so let's now get the resultant first in terms of in vector form and also its magnitude. Now, recall that we said resultant force Fr is equal to sigma Fx plus sigma Fy. Of course, my resultant force is now equal to, we got sigma Fx as 199.1348 Newton I, plus we got sigma Fy as 14.2935 Newton J. So you had this. Alright, so if you factorize this, we have that sigma Fr is equal to, perhaps let's use this, perhaps you could use two decimal places for each of them. That would give me 199.13 I in two decimal places plus 14.29 J all in Newton. Alright, so this becomes the resultant force in your x and y coordinates, or in vector form. This is the resultant force. Of course, we have to find the magnitude. We said the magnitude of the resultant force Fr is as easy as take the square root of Fx squared sigma Fx all squared plus sigma Fy all squared. That's equal to the square root of sigma Fx 199.13 squared plus sigma Fy 14.29 squared. Alright, so this is equal to, I'll just have to square each value and get the answer. 199.13 squared, that gives 39652.7569 plus 14.29 squared, 204.2041. Okay, it gives me this value. If I sum them up, it becomes the square root of 39652.7569 plus 204.2041. Alright, so this gives me 39856.961. Okay, so therefore the magnitude of the resultant force Fr is equal to the square root of 39856.961. That's about 199 points in two decimal places 64 Newton. Alright, so I have this. So this becomes the magnitude of resultant force. Let's get the direction of resultant force. Direction of resultant. Alright. So we said formula is tan theta is equal to sigma fy all over sigma fx. So we're saying that tan theta is equal to sigma fy, that's this 14.2935 all over this 199.1348. Alright, if you want to, you can see the approximated value. You have the same answer, or at least approximately the same answer. Okay. So from here, tan of theta is equal to 14.2935 divided by 199.1348. That's about 0.071723. Okay, so that's like 8 approximately. So 8. So hence theta is equal to tan inverse of 0.0718. Alright, so theta then is equal to tan inverse of 0.0718. That's about 4.1. Okay, so 4.1 degrees. Let's say this. So if I'm asked to sketch, or say draw the diagram, what will it be? This is a positive angle, so it means to be the positive direction of x. So I'll have something of this manner. So this is positive of x, so to be here. The angle is very small. So somehow your 4 degrees is very small angle. So perhaps this will work. You have FR. Okay, since I'm using the magnitude, so FR is equal to 199.64 Newton. That's the FR value. That's the resultant force. Theta here we said is 4.1 degrees. I'm drawing this angle very small because the angle is small, and I'm facing this to the positive of x because the theta is a positive value. Alright, so this is how we solve this example. So look at one more example, and that's for this topic, this lecture.